Look, today we will see one interview question like there are monolith applications and microservices. So, what are the advantages of microservices over the monolith application? So, we will see some details regarding monolith application. In monolith application, development is very simple because only one application is there and everyone need to do development in that. Okay, and deployment is also simple because only one instance will be there and the same DB it will share. And if we deploy the same application as WAR or EAR, then the job will be done. And small teams, suppose we have, and they are using monolith application, then it's perfectly fine for them because the cost involved in microservices is very much high. So there are very few cross-cutting concerns like suppose we need to implement the logging, we need to implement the transaction management. So those will be fewer there in monolith. So the performance is also better due to no network latency. So all the calls will be like synchronous calls in monolith application. So performance is quite high. So there are these are some advantages, but there are some disadvantages also. Those are cons. And if we want to adopt a new technology, suppose we want to change anything, okay, the code base is huge, so we will not able to change that code base using if we use monolith applications. And single code base is there, and as we keep adding the components, as we keep adding the changes to it, and it is very difficult to maintain that component, and performance also gets slow. And debugging and all maintaining that huge code base is a very painful task. So fault tolerance is not there. Fault tolerance means suppose something goes wrong, then how to roll back the changes. That mechanism is not there in monolith applications. Uh, Suppose we want to just change any database property. Okay, in let's say application dot properties, we want to change something. Then entire code base need to build it, need to test it on lower environment, need to see means everything is tightly coupled. So full deployment is needed even if we want to update a tiny change. That is the disadvantage. So how the process works in monolith application, every team develop the code and deploy on same DB. Jenkins pipeline will run and the package will be created as a jar or var, and that will be deployed on any server, application server or web server. And it has a very single DB will be shared by using application, or ER or WAR contain the UI code, Java code, DB code inside it and can be deployed on the server. And after that, some service oriented architecture is also there. So here UI and Java code are separate. They made it like separate, but it is also very difficult to manage. Separate deployment on separate server, that advantage we quietly get on service oriented architecture and um, that quite advantage we get, but still it is very much difficult to deploy the code. So some cons are there for service oriented architecture, like it is very complex management and high investment cost is needed because a middleware comes into picture in that, and that is ESB, that is enterprise service bus. And for that enterprise service bus we need to pay so much amount of money, and that's why service oriented architecture, SOAP or SOA protocol also, it is very costly thing. So people are slowly moving towards the microservice architecture and Spring Boot. By using the Spring Boot, we can very easily achieve the goals. Okay. So in microservice, what are the advantages? Like independent services are there. So cards, payments, payments, accounts, all these small microservice we can easily deploy it. We can scale it. Okay, we already saw in previous our microservice related videos, how to create and scale some microservices, how the load balancing will happen in microservices automatically, and how we create the config servers. We can separate out everything, and we can decouple our logic and all the cross-cutting concerns very easily in microservice based architecture. Independent deployment, suppose we want to make changes in payment related service, then only with payment related service we change it, and we need to deploy it. No need to touch any other microservice like cards, account, loan. mm, all these microservice we no need to touch. Only the uh, given required microservice we will change and test. Scalability is there in the microservices. And suppose we want to scale our applications, okay, on based on load. Suppose uh, Amazon is there. Okay, on Amazon, suppose Amazon sale is there, and in that scenario, we we want to increase our instances from 1 to 100. Then we can, yes, definitely, uh, on as many ports we can deploy that image. Okay, development is very much faster because code base is separate, so n number of teams can involve, and parallel development can be happen using this microservice. Fault tolerance is very much achieved in microservices. We can use resiliency for J, such kind of libraries, and we can implement fault tolerance like circuit breaker design pattern. Okay, so if anything goes wrong, we can fall back to you know uh, normal way, or we can give failover messages to client very easily. So configuration is very much easy. Boilerplate code is not there, and development is very much simple, because auto configuration also we can add in Spring Boot. We can create a different altogether config server. Okay, or config server we can create different altogether, and dynamically we can load the configurations, so that no need to make the code changes and all, and no need to deploy it n number of times. Suppose, let's say, in our application it is a requirement like in frequently we are changing the properties. Okay, so the configuration server we can separate it out, and all the configurations we can add in that configuration server, and then we can separately deploy that configuration. And using the refresh API, you know uh, some actuator refresh APIs are there. Also, we can use any webhooks for that, so that no need to change or redeploy our main applications, and those properties will be automatically get updated as and when required, so no need to deploy it again and again. So embedded servers are also there, Tomcat, Jetty, all these servers are there. So no need to create a separate war file, and no need to create a separate EAR file, and no need to deploy it. We can use embedded Tomcat servers to start and stop the applications very easily. So with different flexibility changes we can add, different technologies we can add, different databases. Say databases are separate for each and every microservices. So service discovery is very much easy using Eureka server. We already saw in our microservice video. In that Eureka server we have added, right? And in that Eureka server, every microservice will get registered to that Eureka server. Then our gateways also using will get registered to that server, and discovery of the services, and with n number of instances are running for your microservice, then it is very easily Eureka server can provide those information to gateway, and gateway can route the request to the individual microservice using the round robin fashion very easily. So API gateway integration, just now we saw load balancing will happen, client side load balancing will happen, and we can add the security layer also in the same uh, API gateway layer. So cloud ready features are there. We can easily integrate with Docker, Kubernetes, and we can containerize our deployments. So maintenance is very much easy because smaller code base is there and maintenance is very much manageable. Okay, and production ready features are also there. Actuator is there, health check is there, matrices and monitoring support is there. On Grafana also we can integrate very easily to check the logs and all. Okay, and CI/CD pipeline also we can implement, we can coordinate with it, and we can enable the faster deployments. So overall, if your code base is large and mm, then a number of teams are there, and those you want to separate out your monolith application, then you can easily start for migration also. Strangler facade pattern is also there to uh, change your monolith code to microservice code. So yeah, that's it. Yeah, thank you.